Hello, I'm Carter Keelan. I will be a junior in this upcoming fall semester that I want to be in LA for. For why I want to be a chemistry LA, I'd like to start for why I got into chemistry. I'm sure you don't mind hearing that. So I originally came here BME because I really liked math, calculus, all that. That was my jazz. But I took Bleem, 101 with Bleem, my freshman year and realized, wow, I really like chemistry. And saying I didn't really take chemistry in high school, I mean, I took it, but it was COVID year, so it doesn't really count. But I really liked chemistry, and I was like, wow, I want to do this. So I switched to chemistry. And for why I want to be in LA, my senior year of high school, we didn't have a Calc 2 teacher, so I would do the lesson plan the night before, then come and teach people. And that's when I realized I really like teaching. It's very satisfying to see someone struggle with a concept, and you come in, explain it to them, work with them, and they're like, oh my gosh, I get it. That very satisfying to me. And I still continue to do this with peers in the classes, any class in general at all. Doesn't matter. If I can help, I will help. And for how I'll help students develop study strategies and learning strategies, for me, it's whenever you get a question, don't make it complicated. Don't overcomplicate it. Just read the keywords in the question to figure out what you're solving for. And once you know what you're solving for, then you work backwards, be like, okay, what formula do I need? And another learning strategy is, the way to get good at something is to do it a lot. So I'm a big problem set person. I'll just download them on my iPad and just do that. So I'll help them with that. But for me, it's how do you answer the question? You need to figure out what you need to solve and how to get there. Once you get that, the questions are easy. Everything else is extra information. So that's how I'm going to do it. And next, hopefully I can edit well. I'm going to do a problem, a Chem 102 problem, but it takes ideas from Chem 101 because I'm okay with either of those being a learning assistant. But yeah, I'm going to end this video and hopefully edit it well. So this is a problem from Chem 102 early in the semester, but it draws on Chem 101, so I thought it'd be a great one to have. I'm going to go through this a little quicker than I would want to, mostly because my intro is long. So I'm going to get straight into this. First thing that we see that we're going to solve for this, which is the product. So if we need the product, let's just make the balance reaction so it's easier to look at. So we got N2 gas plus O2 gas goes to complete arrow, it's not equilibrium, complete arrow, but I don't think we've learned that yet, technically. So we got N2O gas. First issue equation's not balanced. The easiest way to do this is just throw 1/2 out in front. Just throw 1/2. And let's not forget to label this reaction is that. And after we get that, since it wants us to use the best Lewis structures, let's make some Lewis structures. So for this nitrogen, we got boom, boom. We got 2 of these. And I would explain this better, but I know this from memorization. We go boom, 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 boom. Perfect. We're done with that. And let's focus on this oxygen. Everyone know oxygen, double bond, boom, boom. Lone pairs. Let's get those on. Got the lone pairs. Then this is the focus because best Lewis structure, this is what we're referring to. N2O has 3 Lewis structures. For sake of time, I know which one's the best. So let's go boom, 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 boom. Then we get 1, 2, 3, 4, 5, 6. And let's not forget these over here. The reason this one's the best is the charges on this is -1, +1. We want the most electronegative atom, which is the oxygen, to have the negative charge in comparison to the other Lewis structures. So we're going to be using these. But we need to focus on what bonds are forming and which bonds are breaking. This N2, find it back over here. So that one's staying. We're good on that. This one, this oxygen, we only have one oxygen over here. This bond is breaking. So we break this one. Break. And since we broke that one, we're going to be forming this one. Form or make, whatever you want to call it. So now that we have that, we can write it out a little more math-like. So the delta H reaction equals, for the delta H reaction, we know it's reactants minus product. So it's going to be this oxygen bond breaking minus this NO bond forming. But we have this 1/2 up here, so we cannot forget that. This is where this table comes in. So we see this oxygen bond, 498 kilojoules per mole, but we have to put a 1/2 in front of it because we're only using half. So 1/2, 498 kg per mole. Boom. And then it's subtracting the products. So here we go, minus, we see what this bond is to form, 201. So we have 201 kilojoules per mole. And this answer, once you just plug it into your handy dandy calculator, we get positive 48 kilojoules per mole for the delta HF of N2